Respected Shri P. Somnath, Chairman, Indian Space Research Organization and Secretary, Department of Space, Government of India. Professor Balram Pani, Dean of Colleges, University of Delhi. Dr. Vinita Tuli, Coordinator, IQAC. Distinguished guests, colleagues, and my dear students. It is an honor and immense pleasure for me to, and of course entire ARSD family, to welcome respected Shri P. Somnath ji and Professor Balram Bani ji in this August gathering and in this seminar room. Sorry. Shri S. Somnath ji. Sir, we are fortunate that you have given your valuable time for all of us and a live interaction with students. I am going to deliver a talk for our students, and in fact, I think that this is a golden experience for each and every one who is present in this hall, that you have accepted our invitation and given your precious time for all of us. Thank you. This is a proud moment for our young minds to get this opportunity for this interaction. Sir, I feel privileged, honored, and express my heartfelt gratitude to you that you have given this valuable and precious times for all of us from your busy schedule. I know how you are busy, but still you considered our request. That is definitely I will remember for my life. I welcome our guest of honor, Professor Balram Pani ji, Dean of Colleges, University of Delhi, and you all know how cooperative, how supportive, and how active Professor Pani is there as a Dean of Colleges. Whenever I call and I request anything from him, he never disappointed me. Thank you so much, sir, for giving me your time. Sir, we at ARSD lay stress on undergraduate research and have launched an in-house interdisciplinary research and innovation project scheme for both, and are planning to launch the central instrumentation facility inside the campus, not only for our faculty members but for our undergraduate students. In fact, there is a rich culture of research, undergraduate research in our college. So our undergraduate students have published many papers with our faculty members in past. As we have discussed in my office, and we have informed you that there is an ecosystem for the research in our college, and definitely your presence will motivate all the researchers and all the students who are keen to join research organization in future, so they will be definitely benefited. It is the unwavering efforts of the college and IQAC that has made it possible to secure all India's 7th rank in NIR ranking released by Ministry of Education. The research publication score of the college was highest among all DU colleges, which speaks highly of research innovations and initiatives of the college. Sir, the college has also been associated with ISRO as a network institute of Indian Institute of Remote Sensing Dehradun, a constituent unit of ISRO. Under this, the college has offered 6 programs here, and many of our students have joined and did this course, and they got certificate also from the ISRO. Once again, I am humbled to welcome you, sir, welcome you all, and thank you for joining us It is a proud moment for all the ARSD family or all the ARSDians. Once again, I will request to give him a big round of applause. Thank you so much.
Thank you so much, sir. Our guest of honor, Professor Balram Pani, is Dean of Colleges, University of Delhi. Professor Balram Pani has more than 25 years of teaching experience. He has published more than 50 research articles in reputed journals and authored 20 books. He has supervised 8 research scholars. He had handled several projects of more than rupees 1.25 crore research grants. He has worked for the upliftment of the education sector through his diverse experience and expertise. It gives us immense pleasure to invite Professor Balram Pani to address the gathering. So please.
Thank you, ma'am. Namaskar. Good evening to everyone. The dais, Honorable Chairman of Indian Space Research Organization, Shri S. Somnath ji, Principal of this college, Professor Gyantosh Jha ji, and my dear colleagues and student friends. It is all about that the IQAC is organizing this program, and it is the well done and well designed. So first of all, I congratulate you for this program. This is also in continuation. Our university, Delhi University, is celebrating our centenary year, and our country is also celebrating its 75th independence. For that, I also congratulate you all. And whenever you say, means all these things means that is this type of quality. Means for the students, you are the young and bright minds of our country. And since you have taken admission in Delhi University, that is a good reputed and premier institute of India, so you are lucky enough to have this admission in Delhi University. So that's why you are all intelligent. Okay? To this, intelligence, when you add your innovative ideas, then you will become the knowledge person. Then you will do something worth which very, very wonderful to our country, our nation. Okay? Means don't think that, okay, means here you are, means you have certain aim and objectives. And this aim and objectives should be very, very crystal clear. And just your principal sir, he has told that the quantum of achievements in the NIRF ranking, accreditation, and other citations and the obligations, everything he has told. Means it shows that you are doing and you are progressing very well in your respective fields. So, whenever your aim and objectives is very, very clear, you will have to generate your interest in that field. Suppose you are in physics or chemistry or anywhere else, whether it is a political science, whatever course you can take, you will have to generate your interest in that field, otherwise you can be success. In a simple way, so that, okay, means I have taken the admission, I will go to the class and come and move here and there. No. You will have to generate your interest in that. After that, you will have to plan it very meticulously and in a proper way. After that, the implementation. And whenever you will implement it, then the success will come to you. And this, the gates for the success is open only when means you have the keys of hard work, honesty, discipline, punctuality, dedication, and commitment to your own work. Then don't worry about the success. It will be coming to you automatically. So that's why, so you, the young generation, you should be happy. Always you should be happy. No need to become unhappy. What is the reason behind it? Nothing. You are the young generation, bright minds. You should be always happy, so that if your teachers, whenever they will come to your classroom, will see these happy faces, you will also become happy. Isn't it? So therefore, without happiness, there is no life at all. Similarly, without dissatisfaction, there is no growth. People say that, okay, I am satisfied with my work. No. If you are dissatisfied, then you will have to generate your interest and you will do more work to satisfy yourself. Means it is the learning process. So whenever you will combine both these, means happiness and dissatisfaction, then so you should be happily dissatisfied, so that you will become very, very successful in your life. So means you are all eager. This is the interaction session with our honorable chairperson of the ISRO and Shri Somnath. You all are waiting for that one. Means I'm not taking your most time. So again, I wish you all the best, and definitely you, the young bright minds, will get some tips from the chairperson of ISRO. Then I wish you all the best and good evening to you. Thank you.
Thank you so much, sir. Our chief guest, Shri Somnath, is not only the chairperson of ISRO, but also a legacy for our engineers and aspiring physicists. It's our pleasure to have sir here with us. So before we start with this lecture, we would like to announce the release of our first physics department magazine. It's our great honor to welcome our respected chief guest and guest of honor to launch the magazine. Thank you so much, sir. We are all keen to hear from Shri Somnath, Chairman ISRO. He is a person with distinct vision and inspiration to all of us. Sir assumed the charge of Secretary, Department of Space and Chairman Space Commission on 14 January 2022. In his previous assignment, he was Director at Vikram Sarabhai Space Center, the lead center responsible for the launch vehicle technology development. Prior to that, he has served as the Director of Liquid Propulsion System Center at Thiruvananthapuram till December 2017. He was the Associate Director of Vikram Sarabhai Space Center and also the Project Director of GSLV Mk3 launch vehicle. Under his leadership as the Project Director, the first experimental flight of LVM-3X CARE mission was successfully accomplished on 18 December 2014. He has been the Deputy Director of the Structural Engineering Entity in VSSC and also the Deputy Director of Propulsion and Space Ordnance and Entity in VSSC till November 2014. He assumed the charge of Director VSSC in January 2018. Under his leadership, VSSC has achieved significant feats like crew escape system demonstration through pad abort test, launch of GSLV Mk3 M1, Chandrayaan-2, launch of 50th PSLV, PS4 orbital platform experiments, etc. He also mentors the development of small satellite launch vehicle with various innovative technologies and production methodologies for cost and time optimization. He is a Fellow of Indian National Academy of Engineering, Fellow of Aeronautical Society of India, Astronautical Society of India, and member of International Academy of Astronautics. He also serves as the primary spokesperson for ISRO, representing the organization to the public, media, and government agencies. They work closely with other national and international space agencies to promote cooperation and collaboration in space exploration and research. His contributions are not just limited to the science community, but are playing a key role in building a strong nation. So without taking much time, I would like to invite Sir to deliver the talk and have an interaction section with students. So please.
No, it's okay. I'll go.
Okay.
So, good evening, all of you. Professor Balram Saini, the principal, your IQAC coordinator, and all your faculty, students. My greetings to you all. Thank you for giving this opportunity to come to this college and then get to know all of you. So, take it as a privilege to meet you people. The future of India is here. The physics students, they are not the only people who are going to make the India, don't worry. There are many more. But then I'm very happy particularly to speak to the physics students because I love physics so much. I loved physics so much, but I later diverged from the physics or science stream into engineering stream. Of course, it has some little bit of physics and mathematics in engineering as well. So it's not totally devoid of physics, I believe. And I had opportunity to study greater detail in various domains in engineering, of course in physics, which is the integral part of it. And I had the opportunity to work in space sector, in building rockets and understand rockets and space technology a great deal. And Professor was telling he has taught for 25 years. When I was looking back, I have been here for quite much longer than that, 37 years in this business. So it's quite a long time in my career. So I was thinking what I should speak to you people, budding scientists, physicists of the future. What I thought when I stand here, I look at universe. I think universe is something that always looks, when you look at it, as really wonder. Have you ever wondered about it? Looking out into the sky. And if you don't know how to wonder, I think better don't take physics. Huh? The first quality that you should have is to wonder. I think you realize that you don't really understand what is going around. Little bit I understand. But there was a story long back, one of the greatest physicists of all times declared that everything that is required to be found in science or physics is already found out. There is nothing left to be found out. All rules and laws or required of physics are already found out, he declared. That was in 1940s. But today we know, we realize that today we know much less than that we actually should know about the structure of the universe. We really don't understand even today. Do you believe that you understood about the universe? No. Of course you don't. Why? Say, you just imagine for a moment, you look outside and look at the stars in the sky, and all stars are blinking nice, it looks very beautiful, but you realize that none of them are there. They are all the picture that is painted in front of you many years back. Not yesterday night. No, we are not seeing the image of yesterday's night today. Few years back, the closest star to your Milky Way galaxy is just 4 light years away, no? Which is a star? The closest star to solar system is Alpha Centauri. It's just 4 light years away. That means if you are seeing a star in the sky today, if it is Alpha Centauri, then the star was there 4 years back. And the light which you are seeing now is the light that emanated from the star 4 years back. And the closest star is 25 light years away. And the next star is 100 light years away. Then 1000 light years away. That means you just imagine all the stars that you see in the sky are not there today. They were there 4 years back, 25 years back, 100 years back, thousands of years back. So what are you seeing really on the sky? It is the past, right? So you cannot see the present when you look out to the universe and look at sky, look at stars, galaxies, nebulae. All of them are not there today. None of them are there today. You are seeing the history. The history of the universe only you are able to see. Now just imagine that you put a telescope, powerful enough like James Webb telescope, which is recently launched, and the one which was earlier were there, which is the one previous to that, one of the most popular Hubble Space Telescope, and prior to that, anybody know? Kepler, Chandra, all these telescopes were looking deeper into the universe. And they were seeing, what they were seeing? They were seeing the past. None of them are seeing the present. When you look outside, you are seeing always the past. You realize that? Because light takes a finite amount of time to travel from somewhere to somewhere. So what you are actually seeing is the past. Okay, and the distance is more and more, you are seeing more and more into the past. So the power of the James Webb telescope is that you can see light from 13.5 billion light years, billion years back. So the light that started from the point in space at that time, 13.5 billion years back, if a light started, it is still traveling. You know, if somebody is not stopping the light, it is still traveling through the space. It cannot be stopped. And today, if you put a telescope powerful enough to gather that faint light photons that are coming, very rare photons, and if you can collect on a detector and look at it, you are able to see even now the objects that existed 13.5 billion years back. Is it not wonderful? Yes. Human beings are capable of seeing the past so many years back. That's the power of the telescope. That's the power of the space technology. If you put an instrument up in the space and able to see deeper into the universe, you can sometimes be able to see the up to what point you can see? Origin of universe. How many years back? Around 15 billion years back. That much deeper you can see. Beyond that you cannot see. Of course you cannot see, because that's the time that we have calculated the universe originated from the Big Bang, of course, right? So this is the power of space technology. If you are sitting on Earth, you cannot see all of that. What you can see is only the stars. But if you want to see deeper into the structure of the universe and understand how the universe is created, the only way is to go to space and then see. And space gives you such an advantage that you are not obstructed by anything. The atmosphere, the influence of other objects, etc. So in the last 25 years, human beings have gathered so much knowledge about the structure of the universe. It's purely from space technology. About our ability to build such powerful observational platforms like Chandra Observatory, the Hubble Space Telescope, and the recent Kepler, and India to put one observatory. Are you aware of it? Many of you are not aware of it. We have launched a satellite called ASTROSAT. ASTROSAT is a multi-wavelength observatory, but not looking huge like the Chandra or the Hubble, but it is quite big enough to observe the deeper universe and understand the structure of the universe, planetary system, explosion of stars, black holes, etc. We can study very well. It has produced so much of publications using this observation. It is one of the very unique satellites that we built. You can see across spectrum of observations. Do you understand when I say spectrum of observations? You are aware of the electromagnetic spectrum? Yes. You are studying from one frequency to another. And what human beings can see are so narrow. Even if you really draw the electromagnetic spectrum and look at, human beings are incapable of seeing anything in the universe, really. Your ability to detect is actually extremely small. Whereas the entire radiation spectrum, electromagnetic spectrum is so, one and the other is so much. And so much of energy is happening in this, and you are unable to see any of them and feel any of them. So such an incapable human being we are. But still we are able to understand all of this, right? This is our power. Using our brain, we can see all of this. Huh? If you are not able to see X-ray, we will convert it to something that can be seen into a film and then look at it, right? This is the brilliance of human mind. So we can see what you cannot see. That is the power that we have. So now let me stop there and then go into a different domain, that what we have been doing in ISRO in space technology. Our interest in space technology started long back, when we were trying to go to atmosphere and measure some phenomena called electromagnetic anomaly in space. And we started launching small rockets in Tumba, where I come from, to understand this, what is happening in space. At about 90 kilometers up there, there is some electron anomaly, and we want to see the particles that are coming from outer space. And they are getting trapped there, and how they are behaving there and creating electromagnetic anomalies, and measure it. This was the thing Sarabhai and his friends started, and this small rocket started launching there. Later grew to this ISRO. And last 60 years it has become some 17,000 strong members doing a lot of work in different domains. We build rockets, we build satellites, we build applications. Every technology you can talk about building this is available in-house. This is the beauty of ISRO. So we have physicists, we have chemistry people, we have chemical engineers, electrical engineers, mechanical engineers, civil engineers, biology people, plant science people, agriculture scientists, forest specialists. All such people are there in our organization, finally to deliver products to the user. So this is the beauty of our organization. So it's not engineers alone, we have scientists, mathematics, postgraduates, doctorates, all such people are there. Some of them will develop algorithms, some will do some calculations, somebody else will find better path to go to Mars than the current route available. So they will calculate what best way you can reach Mars, the optimal solutions of complex problems, etc., etc. So we are a collection of lot of people, and unfortunately I am not knowing all these subjects very well. And it is impossible for any one human being to understand what is happening around. So it's a very complex problem. So my specialization is in rocket design. And I have the fortune to design and work with the many rockets, so that is my strength. So I can understand from end to end of what is in a rocket and help people to design rockets. So that has been my strength. Now coming back to my the growth in space technology. Because you are physics people, I would like to focus more on physics, not into engineering quite a bit. So we have various physics departments in ISRO. There is one laboratory called Space Physics Laboratory in Thiruvananthapuram. We have one important science laboratory at Ahmedabad called Physical Research Laboratory, which is again a very core of physics related work which is going. I will tell you what are the work which is going on there. We have another laboratory at Hyderabad, which is called NARL, National Atmosphere Research Laboratory. We have other laboratories which attached with all ISRO centers and working on physics. We also tie up with other institutions of physics and science, Indian Institute of Astrophysics, which does a lot of work for us. Then there are solar observatories, there are other observatories all across the country. So physics department is very strong, and one of the domain they work is atmospheric physics. You know, atmosphere is a very complex system. There is energy interactions taking place between earth and water, water and atmosphere, the transportation cycle of materials, water and energy across this sector, how sun energy comes into earth and how it gets trapped into various forms, how the cycle is doing. This is one big complex problem. And another problem is the carbon cycle, oxygen cycle, water cycle. All of these are studied in physics cycles. And how it affects our climate and weather, how climate changes are happening, how pollution is happening, how carbon, sequestration is happening. So we deploy a lot of instruments all across the land in India, like flux traverse. We measure it, we transmit to satellite and collect at the center and do some modeling studies on the entire atmosphere. So there are atmospheric scientists, plenty of them, who does the modeling of atmosphere, various interactions between them. This is one major domain. And many of the laboratories have a lot of observations like radars, physical instruments, etc., to understand the variation of various particles, including carbon, dust, etc., how it is transported, how it affects the climate, etc. This is a very important study in physics in one domain. And another domain is the planetary studies. Go outside, look at sun, moon, Mars, other planets, Jupiter, and find out its structure, their gravity, their materials, their composition, how they evolved. The planetary science as a whole, there are a lot of people, they study objects that are falling to Earth like asteroids, they study the materials in this, where from it originated. So I want to tell you a story which is very interesting at this moment to you people. Are you following me right?
Yes.
Not boring, right?
No.
Okay. So, when I say all you people are children of stars, do you believe that?
Yes.
Yes.
All of you know it.
Yes.
So, why do you say? Explain to me.
Because we are made up of stardust.
Stardust. You call it stardust.
All of the elements came from the death of the stars.
How do you know this? Okay, let me ask you another way. When did you know this?
I knew this when I was curious about how all elements are built in this universe. So, like, the universe started with hydrogen and helium, but how the heavy elements formed, which are we made up of? All of the planets made up of?
Okay, I think he knows it very well. I think I won't take time to explain it. See, the interesting part is the formation of elements from hydrogen to the heaviest elements over a process of explosion of stars. It's an interesting problem, right? And you know, it cannot happen in the explosion of one star. It has to happen in thousands of stars. This is the interesting part. Because the heavier the star is, the higher elements will be produced. And if you are the smaller star, you know today by the calculation that the sun, even if it explodes, it will not produce iron. You know that. It can produce at the best carbon. So its mass is such that it can at the best produce carbon, and beyond that there will be no more further explosion. But if you have to produce next level of carbon burning together to form iron, then it has to be bigger star. Then think of uranium. If you have to really produce the higher and higher elements, what has to explode? Stars, possibly billion times bigger than the sun, should have exploded to produce the elements that you see on the earth today. So you can understand that you have hydrogen on earth, you have oxygen on earth, carbon on earth, iron on earth, cobalt, now you go to the higher and higher elements. That means it's not from the explosion of one star or even 2 stars or 3 stars. We are the results of explosion of millions of stars. Just understand that. So and all the stars have originated, they are burned, they ended their life, they became the dust. From that you are produced. And you know another principle, the bigger the star is, it will burn out faster. You know that? If a million times bigger star than the sun will burn out million times faster. Okay, so the smaller stars live longer. So millions of stars are lived and exploded and died and became powder. It became spread across the universe. It coalesced to form the objects like the earth today. From that the life originated. Because that could happen, then we could be a human being today. If the iron was not there in one explosion, if iron is not the end product of an explosion, then iron simply won't be there. Just imagine. An appropriate star of the size that will finally produce iron has to be there. If there is still bigger than that, iron will not be there. The higher element only will be there. Otherwise it has to decay to produce iron. So it's a very complex problem. Those physics people will understand this. So it's such a complex thing has happened in over billions of years to produce almost every conceivable element on the surface of Earth. Just imagine, such a wonderful thing to happen. And all this knowledge came in just last 30, 40 years only. Do you know that? It was not there even 100 years back. Human beings never ever knew that where from all these elements came on surface of Earth. This whole knowledge came from the observation of exploding stars, called supernova. The supernova explosions were observed using the space technology. Without that, human beings would have never ever known about the principle of supernova explosions. And this came from the observation of the Chandra, the Kepler, the other observatories. So just because human beings were able to take in rockets these observatories up in the sky and place them, we were able to understand the structure of the universe and stars dying. Today, you know how many stars are exploding now? A simple calculation tells millions of stars are exploding in the time span I am talking today. So the simple calculation on the structure of the universe tells us that today, just now, millions of stars are exploding and millions of stars are being created. So it's such a complex energy structure which is running around, and human beings are just not aware of it. And if you look deeper into the sky, sometimes you had a chance to see that one of the millions of the stars that are exploding, and the other remaining million minus one stars you are unable to see. Just imagine such a complex space you are living. You know, recently, sometime back, maybe 5-10 years back, Hubble Space Telescope did an experiment. They decided to look at one of the darkest corners of the universe. Darkest corner means there was no light coming from there, and they decided that I will look at that darkest corner. And Hubble Space Telescope was turned towards that location, and they kept the lens open for 10 days because light was not coming. So if there is no light, there will be no image formed. So they thought, let us try. So they kept it open for 10 days together, and after 10 days they closed the shutter because they have to keep the station very stable. And 10 days they kept it very stable, and at the 10th day they opened the image and developed the image and looked at it. To their wonder, what did they see in that image? Full of what? Galaxies, not stars even. Every galaxy next to it, another galaxy next to it, another galaxy, packed galaxies. And that is a region in space where not even light is coming. What is the explanation of this? That means the entire universe is created of so much of galaxies that human beings are not even aware of. And you human beings have no ability even to understand it. Today you know that the mass that constitutes the entire universe is much, much higher than the mass which is visible. Did you know that principle? Okay, there is a dark matter, dark energy principle. So there is huge amount of mass which is not even we are aware of. And this is the macrocosm. Now go back to the physicists, people will also study the microcosm, right? You will also study about atomic structures, you will study about nucleuses, you will study about electrons, the structure of electron, and what is it constructed of, the basic particles. You study all of that. And what is finally, you know, that what is it made of? Everything is made of what material?
Atoms.
Huh?
Atoms.
Atom is that 1960s, we know it. Today we know that everything is made of what material? Quartz. Quartz was unknown in 1990s or even 80s. Today what do we know? Strings. Okay, maybe better. So today we know everything is made of strings. Huh? That is your close. So the string theory is simply a theory, mathematical expression of what you know today, because material definition of matter is very difficult. So they are going to the mathematical definition of materials. String theory explains every basic particle is constructed of strings of various tensions and various structures, so that every string can take the nature of the electron, proton, neutron of any basic particles, and it will form. Even gravity can be explained as a string in different form. Electromagnetism is described as another string in different forms. So mathematically it is very perfect. Today you know that how many dimensions are there in space?
11.
Very good. You have read that somewhere. You have read about string theory. So 11 dimensions. So 11 dimensions, can you even visualize?
No.
How many dimensions you can visualize? 4? Okay, 4. 4 also you can visualize if we are trained to visualize the 4th dimension. You know physically you can visualize 3 dimensions, but the 4th dimension doesn't get in. But then in schools you know there is a 4th dimension called time, so you are trained yourself to understand there is a 4th dimension. Beyond that you don't even understand. So the human beings have an ability to understand only 3 dimensions, and you will never be able to understand the 11th dimension. It is our limitation. It is like what we said, the electromagnetic spectrum is so wide, you are able to see only this much, but you have created the intelligence to understand from one to another. Same way, human beings have created the intelligence to understand the 11th dimension, and the whole universe is constructed of 11 dimensions, and many of the dimensions are shrunk to a size that you are not able to even see it, visualize it. This is what they say, the string theory says. So it's such a complex physical and mathematical principle that govern us. But underlying all of this, there must be something very, very simple which you have never found out till now. Hopefully, we will find out. Now, let us go back to space technology. The only thing which excites me today as a scientist in rocket science, because it is only through rocket technology you can travel outside the gravity field of Earth, right? There is no other way today. If you ever want to go to moon, how will you go? There is no other way. You have to have a rocket, you have to fire it, you have to get velocity which is above 11 kilometers per second, then only you can escape gravity, then only you can go to moon. There is no other way. So when Christopher Columbus started looking from Britain to travel to find the unknown Americas, he had only one way, only to have the ship. So today the future of the ship is only the rocket. So human beings, as natural nature of their is to travel and explore the universe, which is very vast and wide in front of him, he must resort to the rocket technology. He has no other way. And when Christopher Columbus started, he had no idea where the America is. He was just traveling towards some direction. Hopefully he will meet America somewhere. But today when we travel to Mars, we at least know Mars is there. And if you calculate like that, you will likely to reach there. Somebody in ground is watching with the radar and looking at him, are you going in the right direction? You can actually tell him. So the safety of travel today is very, very high. Not like Christopher Columbus traveled to unknown Americas. So you should definitely build rockets and travel. And this is my excitement all the time. We are able to build rockets today. And I can tell you space technology is still in its nascent phase today. We have still not made great progress in rocket technology, which was invented in hundreds. The chemicals, if you fire, put through a nozzle, it will produce thrust. That has not changed over the last 100 years. It is same rocket only is being built in higher and higher levels of technology. And I am waiting for some technology marvel to happen here today. The velocities that you can get in rocket technology is still very low. If you want to go to Mars, how many months you will take? 6 months. Think of human beings traveling in a confined space for 6 months to go to Mars. You will get terribly bored. Sometimes you will die also. So it is not an easy thing to travel to space and go to distant objects like Mars. If you want to go to exoplanets, you know exoplanets?
Yeah.
Heard of them? Exoplanets are the planets where similar Earth-like situations may be there, then they are rotating about other stars. And you know these stars are at least 1,000 light years away. So if you want to travel to that exosolar planet, you need to spend at least 1,000 light years away. Human life, how many human lives are to cross? Even if you travel at the speed of light. And there is no possibility in the current technology to reach up to that. No? There is no way, unless we two people marry and their families travel like that. Children after children, they go. Sometimes they may reach. Otherwise, you want to be put in suspended animation. No? You want to freeze you to undock situation, and another switch will switch on once you reach there. And you can switch on and then come back to life as you see in science fiction. There is no other way. But I am very sure in the next 100 years, human beings will solve these problems. I have no doubt about it. If you simply go back in history and look at the history of science and technology, most of those accomplishments that we have today would have looked like a fiction when you tell at that time. No, just imagine thinking of Wikipedia at that time. Yeah? People would have laughed at you. That if you tell me anything, I will tell you what it is. Just tell that you will be looked like a saint or a god man, no, right? If you told this story just 25 years back or even 50 years back. So today you are doing things are just magical than reality. So that means whatever appears magical today will become reality after 100 years. There is no doubt about it. We will find ways to travel far and wide across the universe. Only thing that you must maintain Earth safe and habitable for at least that much time so that you can travel from here. Don't kill the Earth before we travel out of Earth, of course. But I am very sure about we are not alone in this universe. We are never alone. And I am very sure that there are life forms and possible for us to live elsewhere is waiting for us. And if anything can do to travel and planet anywhere else, it is only human being. We are the only people in this living form, in this surface of Earth today, who have the ability to think and find a way to travel. And there is nobody else is there. So because of that simple reason, we must work on space technology. So all of you should support ISRO. So all of us are excited about, not about this thinking. I think we are equally excited about this thinking that in India is one country who people think that we don't have the ability to do things of this nature. Do you think that it's correct?
No.
Whenever I go to Europe or any American country, they actually ask us this PSLV and all that, are you making it or you are buying from somewhere and assembling alone? They really ask me the question, not the scientists there. The ordinary people, they are really doubting us. Are we the real doing something? They are getting from Russia? No, we are actually making it. Oh, is it? So, this is the type of attitude. It was there a few years back. Today it is slowly changing. They are able to see that we are able to take up commercial missions, we are able to offer this, and Indian people are able to conceive and do things on our own. So of course we got a lot of support from Russia and Americans and other people, Europeans, in the early part of our space program. They helped us. But we worked on whatever we knew from them and we developed on top of it. But I don't claim that we have a scale of operation as big as America or China. Of course our budgets are still lower. The annual budget for space program is hardly 14,000 crores, whereas it is 10 times in China, maybe many more times in US. So with this small money, whatever we can do, we are doing it. So it's very important for a country like India to work on it and develop this capability. We can build our own satellites, we can launch our own missions, we can go to Moon or Mars if we really want to go. And we are sure that we will put an Indian in space also a few years from now. And we may also do a moon mission where human beings will go and walk on the moon, possibly. If our country become an economically very prosperous country and we can allocate more budget for it, definitely we will do. There is no doubt about it. There is no lack of knowledge or skill in this country. Absolutely not there. So this is the first confidence all of us should have. That if you think, sit down and work on it, we can do anything that we want. Only limitations that we have is resource constraints are there. And of course, there is a need of political support that is needed for programs like this to mature. If the political leadership doesn't support us, then we are down and dead, right? So we have to continue to tell the decision makers it is so important for this nation to work in space technology because of the reason that we told. Not only for this, we also say other reasons. We help in cyclone monitoring, we help in agriculture forecasting, we help in resource mapping, we help in cartography, we help in fisheries, so many other application domains also built in communication, television broadcasting, business services, etc., etc., etc. So unless we showcase utilization of space technology somewhere, government will not give you money, right? So as much as knowing science and keeping science interest alive, we should also work on the impact of what we do in the society. So all of these are important for us. So as scientists and physicists tomorrow, please keep it in mind, it is not enough that science is not the only goal that everybody will look at. How science is applied to the everyday life of human beings and how it can impact all of the society. Then only there will be an overall support for whatever you do, overall support for the research that you do. So connecting these two are very important. That's called the right type of political positions are also needed for all of you to survive and succeed in physics and in your personal life. Thank you so much. So I start with it now. So I now need to question and answers. That will be more interesting. No, I'll sit here. That will be best.